Let's talk about circulatory fuels. Circulatory fuels uroreactor is turning cow manure into sustainable aviation fuel. Let's dissect this, its environmental impact and what it means, the future of energy. So let's fasten our seatbelts and tell us what's going on with using cow manure as jet fuel, John.
Yeah, so I don't know if it's circularity or circulatory circularity fuels, but they've developed this technology that turns cow manure into fuel at 1/100th the cost of traditional methods. So the way it works is cow manure decomposes in farm lagoons, which produces biogas, which is a mixture of methane and carbon dioxide. So they've developed this compact, they call it an uroreactor, which captures the biogas and converts it into synthesis gas or syngas. And then that can be transformed into actual jet fuel using already established industrial processes. So this is cool because it represents a fundamental shift from traditional methane reforming technologies. So conventional steam methane reformers, they require high temperatures from combustion and cost millions of dollars, whereas this reactor, the uroreactor, uses electric power and operates through a process called dry reforming of methane. So just to get into the chemistry of it, the system employs modified catalytic converter technology to break down the methane and carbon dioxide from raw biogas into synthesis gas containing carbon monoxide and hydrogen. And this reactor actually operates at significantly lower temperatures than traditional reformers. And it can also handle the contaminants that are typically found around agricultural biogas, such as hydrogen sulfide, ammonia, and siloxanes. And that would normally be poison and require expensive pretreatment systems. So this solves a whole bunch of problems and using manure. What are your thoughts on this?
Well, it sounds really interesting considering, we've been blaming the cows for climate change and their farts and stuff. Now we can say, wait a minute, now they can actually save the environment, not do damage, because if scaled nationwide, this technology could produce 42 million gallons of SAF per day, meaning 70% of the US demand.
That's crazy, right?
Yeah, so we could do, 70% of the U.S. demand for jet fuels by processing cow manure. The modular reactor size for as little as 100 standard cubic feet per minute enables flexible deployments. Electric heating near 1,000 degrees achieves efficient reforming with dynamic operational capabilities. So there's the SAF demand, though currently under 1%, is poised for exponential growth under regulatory pressure. So we're going to go see, this effective use from dairy waste aligns with our environmental goals, with economic incentives. It's 100 times cheaper. It takes a lot of methane and stuff out of the air because of the process of cow manure right away. I'm excited about this. I just wonder, does the jet fuel end up smelling any different?
I don't think so, because I think the output's the same. But just so that you guys understand, from what I read, the U.S. livestock farms produce nearly 1 trillion pounds of manure annually. So that's quite a bit of manure. So I'm excited for this. I like that. Again, we're covering something that's gone beyond kind of the theoretical stage, and they've actually, I think they actually have a reactor that's working. So this is great. This is a way for farmers to maybe generate some income by putting one of these reactors on their farms and taking advantage of that and selling the fuel back, right?
Yep. They gain new revenue streams from waste products that previously represented disposal costs. This transformation from a cost center to profit center can significantly impact farm economics. A lot of cattle farmers struggle. And if they have a good season, they make money. But if they have a bad season, they struggle and they're getting incentives. It'd be nice to be able to add stuff to the bottom line to make sure they're actually sustainable.
Yeah. And I like this because the economic model fundamentally differs from centralized SAF production. So it eliminates transportation costs for biogas and reduces capital expenditure requirements from millions to tens of thousands per installation. And so traditional methane reform, and we talked about this, requires steam generation, complex heat integration systems, and sophisticated process control equipment. While this uroreactor, it operates on a standard three-phase electric connection, which is available at most large farms. And so, like you said, the system's compact footprint is roughly the size of a shipping container. So that would allow installation without major site modifications. And the distributed model eliminates the need for biogas pipeline infrastructure, which has been a major barrier to agricultural biogas utilization. So, because since liquid fuels can be transported via existing truck and rail networks to fuel terminals and airports. So, this, the reason why I'm sharing that is because people are like, well, they can't just install these reactors. They need a way to transport them, right? But the way that this reactor outputs it, this makes it very easy to transport it. But I'm guessing that the farms that are closer to airports might benefit more. But yeah, this is a great leap forward.
I think it's fantastic. And I thought I read that you could plug it into a normal power grid.
Yeah.
Perfect. Yeah, that's what I thought you were mentioning there.
The three-phase electric. Yeah.
So it doesn't require anything special. Methane is approximately 25 times more potent than carbon dioxide as a greenhouse gas. So converting manure waste into renewable fuels prevents the methane emission, like I mentioned. So that's particularly beneficial. And it's, part of that creating a closed loop system where waste becomes input for valuable products and, the cycle continues. This will also help water tables, where manure and pollution happens in ground and water tables. The question is how much manure is used in fertilizer? And if we take this out of the equation, does it damage the fertilizer industry in any way?
Yeah. I don't know.
But I'm going to say no, because it says we're currently only collecting 6% of the waste of cow manure waste is being collected. It said that somewhere here. I'll find the statistic. And as a result, that's a lot of loss. And putting something like this means they could capture a lot more of it.
Yeah. But you were talking about how methane is 28 times greater than CO2. Just to put another number out there, methane from livestock operations alone represents approximately 36% of U.S. methane emissions.
Wow.
That's crazy.
Yep.
Yeah.
And it is currently, I've got it right here, less than 6% of manure-derived biogas is currently captured in the U.S. It would definitely be an environmental benefit to grab that.
Yeah.
So I'd love to hear what you think. Is cow manure the fuel of the future? And you be happy to fly in jets that are more carbon neutral using cow manure with fuel? Let us know what your thoughts. So, what do you got going on, John?
Yeah, so coming out in September, definitely gearing up for Elevate. I know you're a partner with Elevate, aren't you, Craig?
Oh yeah, absolutely. So definitely we'll be doing something during the Elevate a week. Probably a flowgrammer event, if nothing else. They're a partner of ours. Definitely go out and check it out. There's a lot of great events going on related to Elevate. That's why I said great events. Sessions, program. Check out their schedule. Check out all the different lines of programs and stuff. There's always good things there. So definitely go check out Elevate. And check out Toronto Starts for our startup drinks, our startup investor drinks, and our flowgrammer events where we help people learn how to automate things in their business. And John, if people need funding, where do they go?
Yeah, come find me on LinkedIn. I just posted some news about the Shred program, but come find me on LinkedIn, send me a message, and we'll talk and see if it makes sense to find some non-dilutive funding for you.
Really appreciate everyone taking their time to watch or listen to this week. We'll see you again soon.
Thank you.